Hello everyone, my name is Alex McGuffey, and I'm a team leader of a senior design project here at Valparaiso University. Our team has been working on a system for the solar furnace, which is a facility that was donated to the university. The solar furnace is a system which will reflect sunlight from a large heliostat, which is an array of mirrors outside, and it will reflect it into the room that I'm currently standing in. This array of mirrors behind me will then take that sunlight and concentrate it at a single point about 10 feet in the air. This sunlight will all go into an aperture of a reactor which will be used for high temperature experiments. Now our project is to manipulate this reactor to raise it 10 feet from a working height of about 3 feet and then shift it left, right, and forward and back to accurately position the aperture of the reactor into this focal point so that all the sunlight can enter the reactor.
Here we have a SolidWorks model of the experimental platform system. The platform is raised along a single vertical steel column from a comfortable working height of about 3 feet above the ground up to the height of the focal point of the concentrator. The platform can also be moved over a range of 8 inches forward and back and over a range of 3 feet left and right with respect to the concentrator. All of this motion is provided by ball screws, which are turned by motors controlled by LabVIEW in an adjacent control room. We chose this design because it blocks very little light from reaching the concentrator from the heliostat when our system is actually in the solar furnace, and also because we can achieve very accurate motion with the ball screws. Now we have already constructed the left, right, and forward and back motion subsystems, but the vertical motion is now outside the scope of our project due to time constraints.
This is the horizontal motion subsystem that Melissa just showed you the virtual design for. So here you can see the forward-backward axis and the left-right axis. All of the components for this were manufactured at Valparaiso University except the motors and these ball screws and linear guide rails and the ball bushings. Those were purchased outside. But everything else here we manufactured in-house. And now Austin will tell you a little bit about the control system.
Now, for a little bit on the control of our project for the horizontal platform. Our controller that we use is the compact Rio from National Instruments, and here you can see it with a chassis, which allows us to put multiple modules in, which allow for 2 different modes of motion that we have right now. The programming used for the compact Rio is in LabVIEW, and with the user interface that we coded, there are 3 different modes of motion. One is manual mode of motion, which is course and fine adjustment, and the other 2 are absolute position and relative position. And now we will show you a little bit of our platform moving.
Now we have this test to demonstrate our ability to save a location and move back to that location. Here Austin's moving it away from a position that he saved, and then he's going to move it back automatically to this very same position.
So in this video, you have seen our team leader Alex give you a brief overview of the background and motivation behind this project. You have heard Melissa give you a brief description of the final design that will be installed in the solar furnace this coming summer. And you have seen Austin and Andrew give you a brief demonstration of what has been completed thus far for the horizontal components of our platform. Our team would like to extend our thanks to our customers, Professors Palumbo and Professor Duncan. And we would also like to extend our thanks to our advisor, Professor Nudahay, for without their support, this project never would have been possible. Thank you for watching, and have a nice day.